Hello students, welcome to my Abhyas. My name is Sahana KS and I am your physics educator. So we were discussing the chapter light, and in the last session we have discussed the ray diagrams based on the lenses, right? How the incident light, when it goes through a lens, what happens and how the images have been formed. So in today's class we will know that the sign convention of lenses. So why is sign convention important? So we have seen like in the last session itself that the distance from the object to the optic center, we call it as a object distance, and the image formed and the distance between the image and the optic center, we call it as the image distance. So these all things are related and you have to consider the signs, so that the signs let us know that what is the defect in the eye when you are having a spectacle, and also what is the power. To know the power also you need the sign conventions. So for this we have a session on the basis of sign convention and on the basis of lens formula and also the power of a lens. So we'll be solving two numericals also based on these issues, like these things. Okay. So coming to the sign convention for lenses. So the sign convention for lenses is similar to the sign conventions of the mirrors. Okay, but here what happens, we'll be using the lenses and there will be the refraction process. So coming to the lens, I have considered a convex lens. So as I have considered a convex lens, so here you can see at exactly this point, if I draw one line like this, then this gives me the y-axis and this gives me the x-axis. So here we have the negative x-axis and here we have the positive x. Here we have the positive y and here we have the negative y. So this, I think you people can relate it to the new Cartesian system. So the new Cartesian system also has the same thing, that is the right side is taken as positive and the left is taken as negative. The topmost is taken as positive and the down, that is at the bottom, we take it as a negative axis. So here at the center we have the optic center as it is. So now if the observer is placed, like how they take the sign convention is, when the observer is on the right side, okay, when they consider the observer on the right side, then the object will be placed on the negative axis. So as it is placed in negative axis, after the refraction, in most of the cases when we consider a convex lens, the image will be formed at the right side. But only in one case, that is when the object is placed between the focus and the optic center, the image will be formed, that is in the negative direction. So what happens in all these cases, that is in all the 5 cases, the image formation will be in the right side. So we'll take that as plus v. So you can relate this u as nothing but the object distance. So this is object distance. V is nothing but it is the image distance. And the distance between the focus and the focal, that is the distance between the focus, if I consider this as focus, and the optic center, we call it as focal length. Clear? So these 3 things are very important to remember, so that it's very easy for us to understand the lens formula. So when I see the sign convention here, this is based on the convex lens. But coming to the concave lenses, what happens? So when we take a concave lens, most of the images are formed virtually. That is, there is a virtual image. So almost all the images are, except for 2 images, all the images are formed towards the left side. So what happens, as it is the image formation is at the left side, then what is happening? You get the negative sign. Okay, that is the negative focal length. And for the convex, you will be getting the positive focal length. So this is like you can say plus f for convex and minus f for concave. So plus f, that is the focal length, will be positive for convex lenses and minus f will be there for concave lenses. So because all the things depend on the focus, especially the focus on both the sides, that's why this conclusion can be drawn from this sign convention. So after this, we'll move to a very important topic, and that we call it as the lens formula. So what is this lens formula and why did they discover this? So what happened when they discovered the lens? Okay, so they came across many things, that is the object distance, the image distance, the focal length. So how can this be used? Because some people had far-sightedness and some people had near-sightedness. So can we apply this process in such like to see the things? So this was a question mark to the scientist. So after all the researchers, they came to a conclusion, and there was a formula as a mirror formula, and that was nothing but it is called as the lens formula. So what is the lens formula? Lens formula gives the relation between the image distance, the object distance, and the focal length. Clear? So what is the relation? The relation is nothing but it is 1 by u minus, it is 1 by v. So 1 by v minus 1 by u is equal to 1 by f. Clear? So this is the lens formula which you will be using it to find out the focal length, or you can use it to find the image distance, and also you can use this to find the object distance. So this formula gives you the exact relation between the image distance, the object distance, and the focal length. Clear? So after this we come across another concept which we call it as magnification. So magnification, m is given by the image distance divided by the object distance, or this is also given by h dash by h, that is height of the image to the height of the object. So for example, you can see here there is an object, okay, I will name this as AB. So it is of certain height, okay, and here there is another object which is A dash B dash, I will name it as A dash B dash. So the relation between the image, height of the image and the height of the object is given by nothing but the magnification. That is, if the image formed is smaller, then what happens? You will get the smaller quantity. Okay, if the image is much magnified or hugely magnified, then what happens? The magnification will be high. Clear? And in this case, what happens? Most of the times, whenever the object is taken, that is, in the case of convex, it will be positive, and in the case of concave, it will be negative, because the image formation will be again in the left side. Because of the left side, what is happening? The magnification for convex lens will be positive because the image form will be at the right, and the magnification for the concave lens will be negative because the image formation will be towards the right, that is towards the left. Clear? So I hope you know this, because we had used this similar formula in the mirrors. Okay, that is for the magnification itself, and for the lenses also we'll be using the same formula. Now we will solve the problems based on magnification and also the lens formula, so that you can know the application of the lens formula and also the magnification process. So we'll solve the first problem based on the lenses, and we'll look into the question now. A concave lens has focal length of 15 centimeter. So there is a lens which has a focal length of 15 centimeter. At what distance should the object be from the lens to be placed so that it forms an image at 10 centimeter? So the image distance is 10 centimeter. I have to find out the object distance because they have said me that it is the object from the lens. I have to find out at what distance the object is from the lens. Okay. Also find the magnification produced by the lens. So I have to check the magnification also. Clear? First we'll just check the solution and what they have given us. Okay. So what they have given us is, first thing, they have given me the image distance. So the image distance which they have given me is 10 centimeters. So 10 centimeter in the sense, what is happening? We have this concave lens. So concave lens in the sense, what is happening? The image will be in the negative direction, right? Why? Because the image will be formed at the same side of the object. We have seen it because there were two cases, and in both the cases, what was happening? The image formed would be at near the object itself. So as we are taking the concave lens, the image distance will be what? In the negative direction. So as they have given us 10 centimeter, we will be adding minus 10. Minus 10 because the direction of the image, that is the image formation, will be done in the negative x-axis. So given first thing is the image distance, that is V is given by minus 10 centimeter. After this, they have said me that they have given me the focal length also. So the focal length will be how much? The focal length given is equal to, that is F is equal to, I have 15 centimeters. So applying this in the lens maker's formula. So from lens maker's formula, we have 1 by V minus 1 by U is equal to 1 by F. right? So we need the value of 1 by u now. So to know the value of 1 by u, what I'll do, I'll just take, that is, I'll just take this inside and I'll just put this outside, that is 1 by v, okay, plus 1 by f is equal to, so this is minus itself because minus 1 by f is equal to plus 1 by u. Clear? So what about 1 by v? 1 by v is nothing but 1 divided by minus 10. Okay. Minus of what about f? F is nothing but 1 divided by 15 and that is equal to 1 by u. Okay. So this I can write it in the form of what? I can write 1 by u is equal to 1 by 30 by solving, because if I take the LCM then I'll be getting around 1 by u equal to 1 by 30 where u is equal to, so that is minus I'll get, so u is equal to minus 30 centimeters. Clear? So after getting minus 30 centimeter, I have to find out the magnification. So magnification m is given by nothing but h dash divided by h, or you can take it as v by u. Okay, so the object is minus 30 centimeter, image is minus 10 centimeter. So what I'll get it around, so v value is minus 10 and this is minus 30. So I'll get the answer around minus, that is it is 1 by 3. Okay, and that is magnification is 1 by 3, and you can just take the you can just take the decimal and you can convert it into the you can take the decimal form also, that is it may come around 0.333 here. So this is how you have to solve the questions. So here you have 1 by v divided minus 1 by f is equal to 1 by u. Okay, and in this case what happens, and because of minus 1 by 10 minus 1 by 15 equal to 1 by u, then taking the LCM, that is we'll get the LCM as 30, so 33 minus 2 I'll get, so that will be minus 1 by 30 and u is equal to minus 30 centimeters, because 1 by u and 1 by 30, so that will be equalized, u is equal to 30. And then coming for the magnification, m is equal to h dash by h, then that equal to v by u, and v is nothing but minus 10, which is the image distance, u is nothing but the object distance, which is minus 30, so altogether I will get around m is equal to 1 by 3. So moving on to the next numerical, what we have. 2.0 centimeter tall object is placed perpendicular to the principal axis. So there is an object which is of 2 centimeters perpendicular to the principal axis of a convex lens. So the object is placed on the principal axis and it is through a convex lens, okay, of focal length 10 centimeter. So they have given me the focal length as 10 centimeter. The distance of the object from the lens is 15 centimeter. So it is the object distance which is given as 15 centimeter. You have to observe here, the question is so confusing that it can take 2 centimeter of the object distance as the object distance, but you shouldn't be taking it because they have mentioned it as tall. Tall in the sense what? The height, right? So this will be the height of the object. Clear? So the distance of the object from the lens is 15 centimeters. Find the nature, position and the size of the image. Also find its magnification. So here I have been given only the object distance and the focal length. Okay. So and there is a object height also. Clear? So in the first case, what we'll do is we'll find out the image distance. So after finding out the image distance, we will just check the magnification. And then we will get to know, in the first case, the nature of the image formed. And in the second case, we'll get to know the position and also the size of the image. Clear? Moving on to the solution. So what they have given me, first write it down. So the given thing is, that is the height of the object they have given me. You can just write it down as h, which is 2.0 centimeters. And then they have given me the focal length, that is f is equal to how much? 10 centimeter. And then the distance of the object they have given me, that is u is equal to 15 centimeter. So as it is a convex lens, what this becomes? This becomes minus 15 because of the object distance. Okay. And then I have to find out v. Okay. And also I have to find out h dash. That is the object image height. Okay. So this much is given. And in the next case, what we'll do is we'll just put the lens formula. So what is the lens formula? Lens formula is 1 by v minus 1 by u equal to 1 by f. Okay. So they have given me the object distance, okay, and the focal length. I have to find out the image distance. So 1 by v is equal to, what do I get? 1 by f plus 1 by u. So 1 by f is 1 by 10 plus of minus 1 by, what happens to this? 15. Okay. So here I have 50 minus 1 by 50. Clear? So after this, this is equal to, after taking the LCM and having all the things, I get it as 1 by 30 centimeters. So you can see V is equal to how much? 30 centimeter, which is the image distance. Okay. So this I have got it in the positive manner. So as it is positive, obviously this is a convex lens, and also the image is formed on the left side. Okay, on the left side of the image, on the left side of the object, that is on the left side of the lens, you can say. So this is a convex lens. So the nature of this we have to check with the magnification. The position is on the left side, and the size also through the magnification only we will find out. Okay, so the magnification formula M is equal to, what do you have? H dash divided by H. Okay, so what is H dash by H? It is nothing but V by U. So now I am not considering M value, I am just considering this value, that is H dash by H is equal to V by U, because I know the value of H, I know the value of V, I know the value of U, so I have to find out the value of H dash. So what happens? H dash is equal to H V by U. Okay, so after H into V by U, what I get? H dash is equal to, what is the value of H? It is nothing but 2. So 2 into V, what value of V is 30 divided by value of U is minus 50. So when I solve this, okay, you will get it around 4. Okay, minus 4 centimeter, which is H dash. So here you can see, right? It is 60 divided by minus 15. 15 4s are 60. That is minus 4 centimeter is the image height, or the height of the image, you can say, which is minus 4 centimeters. Clear? So now you can compare the object, that is, it is H is equal to 2 centimeter and the image is 2 centimeter higher. Okay, that is, you can see minus 4 centimeter. So minus in the sense what it is indicating? It is indicating that the image is inverted. Okay, and we can say the image is real because we haven't got it on the negative side of the axis. Okay, and the image is it is smaller when considered to the object. Okay, you can say it is smaller. Clear? So these are the three conclusions, that is, we have found out the nature, the position, and also the size of the image through a lens maker's formula. So generally, when people wear spectacles, they have certain power. Okay, so that is given by nothing but the reciprocal of the focal length. So what is the focal length? Focal length is nothing but it is the distance between the optic center and the focus. So here we will be learning about the power of a lens. So what is the power of a lens? Power of a lens is nothing but it is the degree of convergence or divergence of the refracted rays. That is, the degree of convergence or divergence of light rays achieved by a lens is expressed in terms of the power. Clear? So this power, what happens is, whenever you have to know what is the power of a spectacle, then this thing will be used. So how much a lens can converge or how much light rays it can diverge. So that depends, and then what happens? The spectacle will be made, because it depends on the eye also, eye lens also, and accordingly what happens? The spectacle will be designed. So coming to the next one, here we have the power of lens, which is given by the formula P is equal to 1 by F. So the power of the lens is given by the reciprocal of the focal length, that is P is equal to 1 by F, and the SI unit of power is nothing but it is the diopter, and it is denoted by the letter D. Okay, so what happens to power when you use the convex mirrors? Okay, when you use the convex lenses, the power will be positive. Okay, and when it is concave lens, it will be negative. So why is this positive and negative? Because see, whenever you go to a doctor, especially the ophthalmic doctor, ophthalmic is the branch where they study about the eye. So ophthalmology is the study of nothing but the eye. So here, whenever you go, they give you a card. Okay, if you have any type of corrections in the eyelids, so they'll give you a card in which they mention the positive and negative. So positive in the sense you have to install a convex lens, negative in the sense you have to install a concave lens in the spectacles. So that is shown by nothing than the positive sign and the negative sign. So what is power? Power is nothing but it is given by the reciprocal of the focal length. Okay, and what is power in physics, like in the physical meaning, you can say the power of a lens is nothing but it is the degree of convergence or divergence of the light rays, okay, achieved by that lens. Clear? So this is about the power of a lens. So this completes the chapter light, and if there are any doubts, please let me know. Thank you for choosing my Abhyas. Thank you.